Here we go with lesson 6.1 notes. We've got quite a bit of rules to deal with the operations of polynomials. The first rule is the product of powers, and you're going to fill in and make sure you do fill in the rule here. I've got pieces missing. It's going to be x to the a times x to the b, so like bases, we're going to add exponents, a plus b. So an example of that would be x squared times x to the fifth. And what happens when you add exponents? You get 7. When you divide, you subtract exponents. So that's going to be x to the a minus b power. Now I do this a little bit different, but it does follow the rules. So x to the 5 over x to the 2 would give me 5 minus 2 is 3. Now, I like to do this though. I like to say you have 5 on top and 2 on bottom. So where do you have more? On top, how many more? You have 3 more on top. So that you can get in your head where it actually belongs. Because if it were switched and the 5 were on bottom and the 2 were on top, we would not have x to the third because we would have a negative exponent. But we'll deal with that in just a minute. Alright, x to the a raised to the b. So when you bring a power to a power, you're going to times it. A times b. So an example of that would be like x to the third raised to the fourth power. Again, the difference between this one and this one is these have 2 bases, so we add exponents. This is a power raised to a power, so the powers are right beside each other. So we times it, so you get x to the 12th. When you have a power of a product, that means you've got something that's times each other, inside parentheses raised to a power. Then you're going to give the power to both. So that's going to be x to the a, y to the a. So an example of that would be like if you had 4x raised to the third power, then we give the third power to the 4 and the x. Now in this case, if you can do the power, go ahead and do it. So what's 4 to the third? Use your calculator if you don't know, but it would be 4 times 4 times 4. Not 12, of course. It's going to be 64 x to the third. When you have a power of a quotient, that's x divided by y raised to the a power, then you're just going to give both of them power. And again with my example, let's say I had x over y squared raised to the third power. I would give the third power to the x on top, and I'm going to give the power to the y squared. But then that's going to follow which rule? It's going to follow the power to the power rule, power of a power. So 2 times 3 is 6. So that's going to be y to the 6th power. Negative exponent says x to the negative a is going to be 1 over x to the a. Now, if you're not familiar with the negative exponent, this is my silly way of looking at it. The negative on an exponent is what I call an elevator ticket. If you are on top with the negative exponent, you ride the elevator to the bottom and you lose that ticket. That minus sign, that negative on the a goes away. So the x to the a takes the elevator down. He was negative on top, he's positive on bottom because he used his elevator ticket. What would happen if you had a negative exponent and it was on bottom? He would use the elevator ticket and ride to the top and sit on top. Okay, so an example of that, if I had on top x to the negative 7, then that's going to be 1 over x to the 7th. But if I have 1 over x to the negative 3, then he's going to ride the elevator to the top, and he's going to be x to the third on top. zero exponent says x to the 0 power equals 1. The number 1, not x to the 1. Anything to the 0 power equals 1. So if I gave you a whole polynomial, x, y squared, z to the 3rd raised to the 0 power, the whole quantity raised to the 0 power, it equals 1. We're going to start with example 1. These say to simplify, assume that no variable equals 0. This assume that no variable equals 0 just means if you wind up with a variable on the bottom, you don't have 0 on the bottom, so it wouldn't create an undefined term. So the first one is just a product. We're multiplying two things. Now, granted, this polynomial, or this is a monomial, is quite long. It's got 3 variables, but it's still only one term, and this is one term multiplied. So I don't forget what I already know, and I already know that 4 times negative 5 is negative 20. Just regular math. Now, I've got d squared times d. So that's going to be adding exponents d to the 3rd, because 2 plus 1, remember that has an exponent of a 1, even though I don't see it, so that's 3. Now, t to the 5 and t to the negative 3. I'm going to go ahead and add 5 plus negative 3. 5 plus negative 3 is 2, so that's going to be t squared. And now I've got v to the negative 4 and v to the negative 1. So adding negative 4 and negative 1 creates negative 5. When I finish, I don't want any negative exponents. So in the end, what's the only term with the negative exponent? The v. So the v to the negative 5, he's going to give up his elevator pass, and the whole term is going to ride the elevator to the bottom. And this is my floor. I go from the top floor of v to the negative 5 to the bottom floor to be v to the 5th. So I've got negative 20 d to the 3rd t squared v to the 5th. Positive because he used his elevator pass. Example 2. Now I'm going to look at the negative 6 over 18. That's a fraction. That's a regular fraction to be reduced. Okay. Now I reduce that to be negative 1/3. 1 on top, 3 on bottom. Now I have s to the 5th over s. So I have 5 s's on top, 1 s on bottom. Where do you have more? On top. How many more? You have 4 more on top. And that's where I get s to the 4th on top. X to the 3rd on top and x to the 7th on bottom. How many do you have on top? 3. How many do you have on bottom? 7. Where do you have more? I have more on the bottom. And how many more do I have on the bottom? 4 more on the bottom. So let's go through that again. I reduce the number, which will be negative 6/18, reduces to negative 1/3. Now I have 5 s's on top and 1 on bottom. So that gives me more on top, and how many more? 4 more. I have 3 x's on top and 7 x's on bottom. Where do you have more? On bottom. How many more? 4 more. Because if you have 3 on top and 7 on bottom, you have 4 more on bottom. But we won't write our final answer this way. Our final answer, we're not going to include a 1 if there's something being multiplied. The only time I leave a 1 is if there's nothing left up top. So I have the negative on the fraction, s to the 4th on top, 3x to the 4th on bottom. And that will be my final answer there. Example 3. Sometimes these are easier if they have a fraction raised to a power. Sometimes it's easier if you reduce what's on the inside first. So kind of clean up this before you start giving a 2 out. It doesn't matter which way you do it. Both will give you a correct answer. There are several ways to do problems like these. But this one in particular has no variables on top and bottom that can be reduced, so I just need to start handing out the square. Now, here's where people make their mistake. How many power of 2's do I give out? Every single piece of this gets a power of 2. So initially, it's going to be 2 squared. That's the most commonly missed one to give to the number. X gets a square. Then everything on bottom gets a square. 3 squared. R has a square, and he gets a square, so that's a power to a power, so that's going to be R to the 4th. S to the 3rd gets a square, so that's going to be S to the 3 times 2 is 6. Z to the 6th raised to the 2nd is going to be Z to the 12th. Now, we're going to come back over here and we're going to do the math. What is 2 squared? 4. X squared. What is 3 squared? 3 times 3 is 9. R to the 4th, S to the 6th, Z to the 12th. Now, a lot of people look at this 4 and 9 and say those are both squares and start reducing. No. If it didn't reduce as 2/3, it doesn't reduce as 4/9. So my answer is 4x squared over 9r to the 4th, s to the 6th, z to the 12th. Okay, I'm going to have m to the 4th, n to the 6th raised to the 4th. So everybody in this parentheses gets the 4th power. So power to power means multiply. 4 times 4 is 16. N to the 6th raised to the 4th. 6 times 4 is 24. That's the first parentheses. The second parentheses, everything gets the 6th power. So m to the 6th raised to the 3rd. 6 times 3 is 18. N to the 2 raised to the 6th is n to the 12th. And then p to the 5th raised to the 6th is p to the 30th. Now I'm going to use the first rule, the product of powers, and I'm going to add exponents. 16 plus 18 is going to give me m to the 34th. 24 plus 12 is going to give me n to the 36th. And then the last one is p to the 30th. He has nothing that he shares. There's no p to multiply. No like base. So there's my final answer. Okay, example 5 is adding like terms. Now, we've added like terms already, but it's important for you to know what like terms are in terms of exponents. So it has to be exactly the same variable and power. Okay? So if I'm adding 7y squared, do I have any other y squareds? I do. So it's going to be 7y squared minus 4y squared. 7 minus 4 is 3y squared. 12xy. Do I have any other xy's? I do, and it's plus. So 12xy plus 6xy is 18xy's. And again, you see how the power does not change, because if I add y squared to y squared, I just get more y squareds, or in this case less because it's a negative. But if I add xy's to xy's, I just get more xy's. It is not x squared y squared. And then the last one is negative 5x squared minus, or negative 3x squared, so it's plus. So negative 5x squared plus negative 3, again, gives me negative 8x squared. So combining like terms. Now, if this were addition and these were not even, I know I've got a question like that on one of the quizzes. If they're not even, you still have to make sure everything got used. But that is your correct answer for example 5. Example 6, again with the like terms. I have 3n squared and 8n squared makes 11n squareds. Plus 1 minus 8 gives me minus 7. The next one is subtraction. Now, when I taught subtraction earlier, you're either a user or a distributor. I prefer you distribute. You guys are not very good at using a minus sign. So let's go ahead and distribute. So the first parentheses stays the same. The second one, I'm going to change all signs. So minus 4x squared, which I don't ever struggle with that one. But it's the next one. It should be minus x, and the last one should be plus 3. All terms should change signs of the second parentheses. Now I'll combine like terms. 6x squared minus 4x squared gives me 2x squared. Minus 3x minus 1x gives me minus 4x. Plus 2 plus 3 gives me plus 5. Okay, next one is just simple distributive property, except now I've got an x that I'm distributing. So 2x times 3x squared is going to be 6x to the third. 2x times negative 5 or minus 5 is going to be minus 10x. The next one is a FOIL. So I'm going to distribute an x squared twice. That's going to give me two terms. So x squared times x squared is x to the fourth, using a power rule. That's going to be a product of powers. And now x squared times minus 5 is going to be minus 5x squared. The next I'm going to distribute is the negative 2. And that's going to give me negative 2 times x squared is minus 2x squared. And negative 2 times negative 5 is going to be plus 10. Now if you'll notice, my middle two terms are going to combine. So my final answer is x to the fourth minus 7x squared plus 10. Example 6, again with the like terms, I have 3n squared and 8n squared makes 11n squareds. Plus 1 minus 8 gives me minus 7. The next one is subtraction. Now, when I taught subtraction earlier, you're either a user or a distributor. I prefer you distribute. You guys are not very good at using a minus sign. So let's go ahead and distribute. So the first parentheses stays the same. The second one, I'm going to change all signs. So minus 4x squared, which I don't ever struggle with that one. But it's the next one. It should be minus x, and the last one should be plus 3. All terms should change signs of the second parentheses. Now I'll combine like terms. 6x squared minus 4x squared gives me 2x squared. Minus 3x minus 1x gives me minus 4x. Plus 2 plus 3 gives me plus 5. Okay, next one is just simple distributive property, except now I've got an x that I'm distributing. So 2x times 3x squared is going to be 6x to the third. 2x times negative 5 or minus 5 is going to be minus 10x. The next one is a FOIL. So I'm going to distribute an x squared twice. That's going to give me two terms. So x squared times x squared is x to the fourth, using a power rule. That's going to be a product of powers. And now x squared times minus 5 is going to be minus 5x squared. The next I'm going to distribute is the negative 2. And that's going to give me negative 2 times x squared is minus 2x squared. And negative 2 times negative 5 is going to be plus 10. Now if you'll notice, my middle two terms are going to combine. So my final answer is x to the 4th minus 7x squared plus 10. Example 10, I'm going to distribute the x first. And that does say minus 3xy, like yours does. So x times x squared is x to the 3rd. Now the x has to distribute 3 times because this is a trinomial here. X times minus 3xy. X times negative 3xy is going to be negative 3x squared y. Notice that all I have to do is add the exponents of the x's. And now x times 2y squared is going to be plus 2xy squared. And we'll usually put them in alphabetical order, xy squared. Now I'm going to distribute the y 3 times. So each individual time I'm doing y times x squared. Again, we'll put them in alphabetical order, so that's going to be plus x squared y. I guess I should write that in blue so you get an idea. Now I've got a y times a negative 3xy. So y times a negative 3xy. This time I've got minus 3x and the y is squared this time. And now I've got a y times a 2y squared, and that's going to give me plus 2y to the 3rd. Now, that's the correct number of terms, 3 from the x and 3 from the y. So let's see if we have any like terms. Exactly the same variables and exponents. So I've got a x cubed. I don't have any other x cubes. I've got a minus 3x squared y. Do I have any other x squared y's? I do. So I got a minus 3x squared y and 1x squared y. What is negative 3 plus 1? So no other x cubes. I'll write that down. Negative 3 plus 1 is minus 2x squared y. Do I have any other xy squareds? I do. Minus 3xy squared. So 2xy squared minus 3xy squared gives me minus 1. And I won't write the 1, xy squared. And then I've got, don't forget about my lone piece down here, plus 2y cubed. So this will wind up multiplying this binomial times this trinomial gave me a polynomial with 4 terms. Go ahead and try number 11. Pause the video and see if you can get it right. Okay, I'm going to distribute the 2n squared times all 3 of these pieces. So 2n squared times n squared is 2n to the 4th. 2n squared times 5n is going to be plus 10n to the 3rd. And 2n squared times minus 1 is minus 2n squared. Now I'm going to distribute a negative 3 to the n squared plus 5n minus 1. So that's going to be negative 3n squared minus 15n plus 3. Now it's plus 3 because it's negative 3 and negative 1. I again look for any like terms. In this case, my like terms are right beside each other. So my final answer is 2n to the 4th plus 10n to the 3rd minus 5n squared minus 15n plus 3. Go ahead and try your practice.